Classification of bridge circuit classified into two types, AC bridge and DC bridge, in which AC bridge depends on inductance, capacitance and frequency. Then DC bridge depends on resistance. Then AC bridge inductance bridge circuit classified into two types, Maxwell bridge and Hay bridge. Then capacitance AC bridge circuit classified into one type, that is Schering bridge. Only Schering bridge in material science subject, other not. Then third one is frequency, depends on frequency. First is Wayne bridge. Then DC bridge based on resistance. Then DC bridge classified into three types, Weston's bridge network, Kelvin double bridge network and Megaohm bridge network. Then Schering bridge. Schering bridge is very important AC bridge used for precision measurement of capacitor and insulating properties. Then the basic circuit diagram shown in figure. There are four impedances are shown in Z1, Z2, Z3 and Z4. Then figure shows that arm1 contains a parallel combination of resistor and capacitor. Then arm2 consists of series resistance R2. Then arm3 contains capacitance C3. It is the standard capacitor C3 is a high quality mica capacitor for general measurements or an air capacitor for insulation measurement. Then in arm4 contains series combination of resistance and capacitor. Then a high quality mica capacitor has very low losses and no resistance, and an air capacitor has a very stable value and a very small electric field. Then capacitor is nothing but two conducting parts separated by insulating or dielectric material. Capacitor, it is a static device. Then insulator or dielectrics do not have free electrons, but however no insulator or dielectrics are perfect. So when capacitor is connected across EMF, so it does not conduct, but they contain small amount of free electrons, which causes very small amount of current flowing through the circuit. Then in Schering bridge, dissipation factor is very important, that is tan sigma. It is denoted as tan sigma. Tan sigma is an indication of state of dielectric. The more its value, the worse the condition of insulation will be. Then Schering bridge widely used for capacity and dielectric loss measurement of kind of capacitance, for instance cable, insulator and liquid insulating material. The most of the high voltage equipment have low capacitance and low loss factor. This bridge is more suitable for measurement of such small capacitance equipment, as the bridge used as a high voltage or high frequency supply. If measurement of such low capacity equipment is carried out at low voltage, the result so obtained is not accurate. The schematic diagram of Schering bridge as shown in figure. Then AC bridge used as to measure inductance and capacitance. Then all the AC bridges are based on Weston's bridge network. Then in AC bridge, the bridge circuit consists of four impedances and AC voltage source, that is four impedances Z1, Z2, Z3, Z4. Then AC voltage source. The impedance can either pure resistance or complex impedance, other than measurement of unknown impedance AC bridge are commonly used for shifting phase. This is general AC bridge circuit. Then null position, a box with a Z written inside the symbol called as impedance. Then Schering bridge is useful for measuring insulating properties, that is for phase angle of very nearly equal to 90. The figure of Schering bridge are shown in figure. R1 contains only capacitor C3. This capacitor is very low losses and no resistance, and therefore the phase angle approximately 90 degree. Then calculate the values of Z1, Z2, Z3, Z4. Then Z1 is equal to resistance and capacitance are parallel. Then 1 upon R1 plus 1 upon minus jxc1. Then Z2 is R2, that is Z2 is equal to R2. Then Z3 is equal to minus jxc3, that is Z3 is equal to minus jx3, that is 1 upon x3 taken as minus jx3. Then Z4 is equal to R4 plus 1 upon jxc. Then Z4 is equal to Rx minus jx4. Z1, Z4 is equal to Z2, Z3. Then obtain the values of Z4 is equal to Z2, Z3 upon Z1 is equal to, put the values of Z2, Z3, that is R2 into bracket minus jx3 upon 1 plus R1 plus 1 upon minus jx1. Then R2 minus jx3 into 1 upon R1 plus, then minus sign is, then minus 1 upon jx1. Then R2 is equal to minus j upon, put the values of x is equal to 1 upon omega c. Then R2 is equal to minus j upon omega c into bracket, then 1 upon R1 minus, put the values of x is equal to 1 upon omega c, then j omega c1. Then rearranging equation, then Rx minus j upon omega c3 is equal to R2 c1 upon c3 minus j R2 upon omega c3 into R1. Then but equating the real and imaginary part, Rx is equal to R2 into c1 upon c2 and cx is equal to c3 into R1 upon R2. Then advantages of Schering bridges, the balance equation is independent of frequency. It is used for measuring the insulating properties of electrical cable and equipment. Then while getting the derivation, we are assuming the bridge circuit having no Schering coupling. The effect of stray capacitance can be nulled by using earth. Sometimes lossy capacitor can be represented by pure capacitance connected parallel with resistance as shown in figure. Then dielectric loss tan sigma for such connection can be given as tan sigma is equal to 1 upon omega cr. Then problem based on Schering bridge. Then find the equivalent series element for unknown impedance of the Schering bridge network whose impedance measurement are to be made at null position. Then resistance R1, the value of resistance R1 is 470 kilo ohm. Then resistance R2 value is equal to 100 kilo ohm. Then C1 is equal to 0.0 microfarad and C3 is equal to 0.1 microfarad. Then solution, find Rx and Xc. Then Rx is equal to R2 into C1 upon C2. Then put the values of R2 is 100 into 10 raised to 3. Then C1 0.0 micro, that is into 10 raised to minus 6. Then C2 is equal to also all the values of capacitor considered in arm bridge is C1 is equal to C2, that is put C2 is equal to 0.0 into 10 raised to minus 6. Then obtain the values of total resistance or equivalent resistance is in the form of capacitance is 10 kilo ohm. Then obtain the values of Cx is equal to C3 into R1 upon R2, 0.01 into 10 raised to minus 6 into 470 into 10 raised to 3 upon 100 into 10 raised to 3 is equal to 0.47 into 10 raised to minus 6 Faraday. Then obtain the values of capacitor is 0.47 microfarad.